Hello there and welcome again to my workshop. Today we're going to do another laser project. I made a video about a week ago cutting out an art-decor grill to fit in a door. Well, I've been sent another file that same guy wants one cut out to go in a bathroom window. So it's all about cutting this out today. And for those of you who are interested in CNC routing and wood turning, the next video or the next series of videos will be dedicated to those. Okay, so my program of choice to start off with is ArtCAM. Now, although ArtCAM has been discontinued, you can buy Carpentry, which is the new name for ArtCAM. A link for that program will be down below this video. Also, Vectric Aspire will do this job just as easy, just as well. And what we're going to use this ArtCAM program for is to convert that JPEG or photograph into something that the laser is going to understand, and that's vector lines, and I'll show you how to do that. Okay, so we've got our ArtCAM program running. So all I'm simply going to do, if I can find it, is drag and drop it straight into ArtCAM. And we'll give it some dimensions. So image size, and we're going to say this is so we've selected 0 height because ArtCAM will automatically try and make this into a 3D relief. We don't want that. All we're after is the vectors. So we press OK and go full screen. We'll zoom into that a little. And it's a very, very nice design of two sort of mirror image trees with some birds and some fruit and leaves and what have you. It's going to be a very nice effect for the bathroom window. So what we need to do is ask ArtCAM to draw around or trace this, and it's called converting this bitmap picture now to vectors. And a vector really is just a line, okay, in any shape, any form. It's a line. So, and there's one tool that will do it that we have to do a couple of little processes with. So that's this tool up here, and it's called bitmapped to vector, which brings up this dialog box. Now, in this picture, I can pretty well guarantee you that there's over 200 colors. We can actually only see black and white, but believe you me, they're there. In actual fact, each little box down here is representing a different color that is in that picture, and I'll show you now. I'll scroll through them just to show you that they are there, and some of the colours was going to surprise you. Greys, all greys, to white. So there's over 200 colours there. So what we need to do is convert that to 2 colours. So ArtCAM understands which colour we want it to trace around. Otherwise it won't understand what we want it to do. And we even choose the major color that we want to turn, we want it to trace around, which is going to be black. And we do that over here in this far corner. So first of all, reduce colors. Well, there's 255 different colors in there. So we're going to say that we're going to just get this drawbar here and slider rather, slide it all the way down to 2 colors and press OK. And you can see it's gone a little pixely Okay, so it's got a little pixely. We don't have to worry about that because in ArtCAM these two here will allow us to will instruct ArtCAM to actually straighten this all out. So speckle size means less than 2 pixels. In other words, anything less than 2 pixels, each little square box is a pixel, ignore it. That's what we're telling ArtCAM. And smoothness, this is just a reference number. Okay, I don't think it's 75%, but it's just a reference number 1 to 100. And this is sort of set about the optimum that ArtCAM thinks this program, or this picture will need. So we're just going to leave the settings as standard, press create, and you see ArtCAM has drawn a vector line and it has sort of evened things out through the entire picture. So we're going to cross out of that and scroll back, and you can see, you might be able to pick out a purple haze, that line. It's done the entire picture and made vectors for us. So what we're going to do now is save those vectors and put them directly into LaserCut 6.1 and further treat it in there. Okay, so what we need to do now is export these vectors as a DXF CAD file. So you do that by going up here to Vectors, Export, and you'll have a list in here, and one of them is DXF CAD, and we better name it. You can name it anything, it doesn't really matter as long as you recognize what it is. I'm going to save this to my desktop. This is just asking about the tolerance that you want to set it at, and this is okay. It's just a drawing vector really. Okay, so now we can cross out of that. No need to save anything, we've done the job with ArtCAM. And there it is there. So now what we're going to do is, if I can find it, there it is. Open up LaserCut 6.1. And come up here to this little icon to import, and we want to import, there it is there, test 3 DXF, and there it is. I've got to go and measure to see what size on his little drawing that I forgot. So I'll go and measure that up and come back to you. Where's my, there it is. Handy little tool. Okay, so what we're going to do, we've already got the selector tool, and we're going to draw a box around it and select all the vectors, and then just come over to one side for this to change, the cursor to change to a cross, right click, size, and in Y, we're going to turn it around in a minute. I want this to be 750. 750, and we got the scale, lock scale, aspect ratio. Okay. Ooh. So now we want to rotate that around. Now that's fairly damn big. Okay. So we come up here, rotate. It doesn't matter which direction we rotate, so we just want to go 90 degrees and press OK. Oh, it fits on my table just fine, because this is set to the size of my table, which is a 60, 90, 600 millimeters by 900, which is rough figures. That's 2 foot by 3 foot thereabouts. And it doesn't really matter where it is on the table. I set the datum for this top corner, and it really doesn't matter as long as I know it fits on the table. Okay. All right. So I'm going to deselect this now. Okay, got it deselected. Now what you must do when you're doing a job like this, of course the sheet is slightly bigger than this. It's actually larger than what this table is. I'm going to have it slid into the laser. But what you need to do now is break this up a little bit, just into 2 sections. Now I'm going to select this outer boundary. Okay, because we want the laser to cut that out. But we want that cut out very, very last. So we're going to set that on a separate layer. I'm going to put that on a blue layer, and you choose the layer down here. The roll boxes, all different colors. So many layers that you can have. If you wanted to select each part of this individually and cut this entire thing out, piece by piece, if you wanted to select a particular one to do first and second, third, fourth, you can actually do that by selecting each individual section and setting it up on a separate layer. So we're just going to do this for the outside at the moment. Blue layer, and you'll see it's actually changed blue, and here we are up here. We now have 2 layers. Now when LaserCut sends this to the laser will actually cut this in order. In other words, it'll do the top one first and the blue one, the second one, second, which is exactly what we want. We want the laser to start cutting out this inside part first, and then very, very last cut the outside out. So now we're going to set up the laser, the power and the speed of the laser. I'll just reposition the camera a little bit there so you can see a little bit better. So what we're going to do, it's already set on cut, so we just double click on that one. It brings this dialog box up, and this is set pretty well okay for what we want to do. I've said before, this laser is an industrial laser, and it's capable of cutting, it will cut it at 50 or 60 millimeters a second, but I really do not like my laser just thrashing around, so I like to preserve it. So I'm not in any particular hurry. It will cut this entire thing out in 20 minutes. And that's fine for me. So I've got it set at 20 millimeters per second of the laser actually in cut mode, which is just look, 3/4 of an inch is around about 19 millimeters. So it's what is that? It's about 7/8 of an inch a second. So it's still relatively quickly. Now this first setting here is work arc. Now what that actually means is you want to punch the laser through the material as quickly as you can. So you give it a bit of extra boost, a little bit more power to actually punch the laser through quickly. When it comes into a corner and changes direction, sometimes due to beam lag, and we'll do a video in the future on beam lag, as it goes around the corner, it just leaves a bit in the corner that doesn't cut. So to eradicate that, I've got that set at 60% as well. Now, normal running power, as you sort of come round the curve like this, or if you're going in a straight line, you want that slightly lower. Oops. So I just touch my elbow on the keyboard here. 55 watts. So you've got a minimum and maximum. Now when you're cutting, you want to set this the same. Okay, so 55 watts and 55 watts. This is also set up for multiple laser tubes in one machine. Some machines have a cutting tube of about 100 watts, and a second tube of about 60 watts for etching and things like that. I really don't see the need for that myself, but the facility would be there. Blowing mode, you should always have it set on blowing mode, in my book anyway. The air delivered to the nozzle is there to blow the debris, the smoke and the gases out of the cut, or out from the laser's view, because that debris, smoke and all the rest of the stuff, it actually has the ability to prevent the laser from cutting all the way through. I mean, it's like smog then, you can't see. Alright, well it affects the laser as well. Even though it might be a small amount, it can sort of be the thing that actually stops you cutting all the way through. So, that problem goes away. Plus, the air coming into the nozzle is there to keep the underside of the lens clean, and also to keep it cool. So in my book, always blow it. Nothing else needs to be filled in. We don't want to give this an XY coordinate start position from the home position. The laser home position is over here. Sorry, over there. And this would be the start point of the program here. And we don't want to designate a certain area on the sheet to go and start, although you could using these coordinates here. And this tells me to this little yellow box there, the laser is going to come from wherever we set the material start position. It's going to travel down here, start here, and go round. I think it'll probably go around that way. But that's all you need to fill in there. So I'm going to press OK. The computer will very quickly calculate all that. Millions of calculations done in seconds. Pretty good Hewlett & Packard computer. So that was the black layer. Now we're going to do the blue layer. And this is set exactly the same, identical. And we just press OK. So now I'm going to transfer that file into the laser, and we'll cut this piece out. Okay, so here we are at the laser. Now I have a sheet of 3mm or 1/8 of an inch ply in here. It's very good ply, and I'm using my honeycomb. I don't often use that, but in this application it's probably the best thing to use. But if you notice, it's bowed up slightly. So what I normally do, these are magnets, okay, and I just put them on the edges here like this, where I know it's not going to get, it's not going to collide with the nozzle, and it sort of holds it from moving, and it flattens it out. like that. And the same with this side. Now the reason you want this to be as flat as possible is because the distance between the nozzle and the work is quite critical. In my case it's 9.5 millimeters. So you know it's a very small margin to be focused absolutely correctly. Now I'm using a 2.5 inch lens, which is the best all-rounder in my book anyway. In the future we'll talk more about lenses and the shape of the actual laser that actually comes out of the nozzle, and it gets a bit complex, but I'll make it as easy as I can for you to understand. So let's set this up to cut. So the first thing to do is to set the Z height. In other words, focus the lens. Now, so we better set the table down a bit first. Okay, we have this is like a rubbery type coated metal plate that you put on your material, and then I'm going to bring the head over and set the Z. Okay, so I'll set the automatic Z now. Okay. So now I'm going to set the start of the program, or where I think it's going to start anyway. I think we're going to be fine there. I like to leave quite a bit, you know, sort of a good ½ inch of material all the way around to stop any sort of flexing or as much. Because I had a little bit of a bow there, I've got to put a couple of magnets there, so I'm going to have to come this way slightly. Not too much. Just to make sure I don't, you know, catch the sensor on that material. So okay, so I'm just going to load up the new file. Okay, I've set the origin. Now I'm just going to do a test and run around just to see whether it's going to lie all in this material. I'm pretty sure it will. And then we're not going to collide with anything. That all looks pretty good to me. Just about got it all on there without any hold-ups. Okay. Okay, so we're all ready, set to go, and what I'll do is I'll video the entire cut of this, but I will fast or high speed the film, because this is going to take about 20 minutes, and I'll play you some lovely music from Google. So here we go. And there is the finished item. And it actually turned out quite spectacular. And it's another project that proves that you can make a business out of your small workshop with certainly a 100-watt laser, industrial grade. Now I do stress that because there's a lot of lasers out there that are really just intended for a hobby. I'm afraid you won't be able to make a business with those. If you go to a specialist to have something like this made for you, they would regard this as a 2-hour job with what they call artwork and laser time. That's cutting time, because they do have to take into account the life of the laser. The particular laser tube that I have has a life of 10,000 hours, and after that period of time you have to change your laser tube. So there is consumables in a laser, and the tube is one of them. So you go to any reasonable shop that has that will do a laser job for you, a custom laser job. Like I say, they would regard this as a 2-hour job with materials, and they charge upwards of $150 an hour. Well, I can tell you that if you're in mass production or something like that, you can have this done in less than an hour. So that actually means you are going to earn, or it's possible to earn, with a 100-watt laser, $300 an hour. And let's face it, anybody who is running a business never works just 8 hours. It's always 10 hours or more. So in actual fact, that particular laser of mine is quite capable, providing you have the work for it, of earning $3,000 a day. You're probably not going to do that every day, but let's face it, it can be a very, very lucrative business. And in the future, I will show you in great detail how a laser works, how to find the right cut, how to find the right power level, and so on. So please like and subscribe, and I'd like to take this point to thank my patrons, because it's the patrons behind this channel that enables me to produce videos like this. On my channel you will find everything about lasers, how to operate them, in the correct way and how to actually make money from, I stress this, an industrial grade laser. Also wood turning, CNC routing, CNC conversion, and virtually everything in between. Programs that operate them, and well, I don't think I've left anything out. So thank you for joining me, and it's bye for now.